Now I'd like to talk about Poisson distributions. So please turn in your study guide to the Poisson distributions section. Now in a Poisson distribution, this distribution deals with probabilities of rare events that occur infrequently either in space, time, distance, area, etc. Now the Poisson distribution is a discrete distribution which takes on the following possible values: x equals 0, 1, 2, 3, so forth and so on. And this can continue on forever. So once again, we have a discrete distribution that's infinite, and x represents the number of rare events that occur in a particular space or time or distance or area, etc. Now in a Poisson distribution, it's often used as a model for the number of events, such as the number of telephone calls at a business, or perhaps the number of accidents at an intersection in a specific time period. Other examples may include the number of emergency room visits that occur per day at a local hospital. Perhaps we're talking about the number of tardies per semester for a given student. Although that may not seem like a rare event, it is for most. And the number of runs per inning in a baseball game. All of these types of scenarios can be modeled by Poisson distributions, where once again the random variable x represents the number of rare events that occur infrequently in that particular time interval. Now let's talk about the properties of a Poisson distribution. The occurrence of a success in any interval, whether it's measured in time or space or distance, whatever, the occurrence of a success in any interval is independent of that in any other interval. And the probability that a success will occur in any interval is the same for all intervals of equal size. And then this is real important. It's proportional to the size of the interval. So if our intervals are not the same size, then the probability of success will be proportional to the size of the interval. And once again, in a Poisson distribution, we observe a discrete number of events in a continuous or fixed interval. Now let's talk about the density formula for a Poisson distribution. Now, the random variable x here for a Poisson distribution represents the number of rare occurrences in a particular interval. Now, the probability density formula for a Poisson distribution is given by the defined random variable x. And if the random variable x defines a Poisson distribution, notice what we use to define the random variable x as being a Poisson distribution. Once again, we use our random variable x followed by the tilde symbol, representing that it does follow a distribution here. Capital P represents that it is a Poisson distribution. And for a Poisson distribution, we have one parameter, and that parameter is the Greek letter lambda. And lambda here is defined as the mean number of rare occurrences in a particular interval. And the probability distribution based on that parameter value of lambda in a particular interval, the probability that there's k rare occurrences in an interval, then the probability that x equals k is lambda to the k e to the minus lambda over k factorial. And that's the probability density formula for a Poisson distribution. Once again, the probability that x equals k is lambda to the k e to the minus lambda all over k factorial. Now the mean of a Poisson distribution is simply lambda. And that's the parameter we define the Poisson distribution by. Once again, we define Poisson distributions by lambda, the mean number of rare occurrences in a given interval. So the mean of a Poisson distribution is defined by its parameter lambda. And the standard deviation, although it's a bit unusual, of a Poisson distribution is the square root of lambda. Once again, sigma sub x, if x is a Poisson distribution, sigma sub x is equal to the square root of lambda, where once again lambda is the mean number of rare occurrences in a given interval. So what's unusual about the Poisson distribution is that the mean and the variance are both lambda. Now let's take a look at using a Poisson distribution in application. Suppose in example 1 here, the number of accidents in an office building during a 4-week period averages 2. That's a pretty infrequent event.